Alright, here's an interesting homemade battery or homemade supercapacitor, if you want to call it that, project that I've spun off into. And it went back to using a magnet arrangement on a cell or a capacitor to see if it did anything at all. And my contention is what it does is it holds the cell tightly together. And anyway, I've been working with that, and I came up with this. It's a very simple, I'm calling it a rechargeable cell, but it had some interesting characteristics, and that's why I made this video. What it is, I'll pan out and just maybe freeze frame this and look at this. It's a couple of non-magnetic food grade stainless steel condiment cups. You can get them at Walmart, or you can order them on Amazon.com. They're very inexpensive. If you go to a store, take a magnet and make sure a magnet doesn't attach to that. That means the nickel and the chromium content is high enough to make it a non-magnetic stainless steel. I think it's 304 grade. Might be 3/16, but the cell is very simple. I used a paper towel as the insulator, and there was a reason I did that. I wanted it very, very thin. When it got wet and got the electrolyte on it, I wanted it to be very thin and then held together tightly with a magnet stack on each part of the cell. The electrolyte, I'm back to Epsom salts and tap water. That's all it is, plain old Epsom salts and tap water. There's a controversy about using that, but it works. And I've done a number of these cells with stainless steel, magnetic and non-magnetic stainless steel, using that arrangement. And this is the cell, and you can see that the dimension between the two plates is very, very close because I'm using these magnets in attraction between the plates of the cell. And I've got a multimeter hooked up here to the cell, and this little reed switch pulse motor that acts as a generator if you turn it by hand. And this is why I'm making this video, because I noticed something that was interesting. If I rotate the rotor in one direction, it will put a charge on the cell in one way. If I short the cell out to zero, basically like that, and rotate the rotor the other direction, it will put a charge on the cell the other direction. And this is indicating to me a capacitive type of situation rather than a rechargeable battery, where you put a charge on one plate and cause a chemical reaction to go back and forth between the two plates. But it's usually stronger in one way than the other way. It doesn't equalize both directions. So let me show you how this works. I'm going to rotate this clockwise this time, and watch the multimeter as I do this. There goes the charge going onto the cell with the rotor rotating clockwise. Okay, now I'm going to stop the rotor here. There goes the cell discharging because the reed switch is closed with the magnet, and this is going to discharge down to where it's almost zero. If I move the magnet away, this will rebound. And we've seen this in other videos where people are showing a rebound and they're suspecting it's the magnets, and I'm thinking it's just the squeezing of the cell. Okay, now what I'm going to do is I'm going to rotate the rotor the other direction, counterclockwise. This is going to generate a current into the cell the other direction. There we go. And there goes the minus. The rotor is going around this direction. It's putting a charge into the cell the other way. Now I'm going to stop this again, discharge it down, move the magnet away. You see the rebound in the negative direction. Here again, this indicates to me I've got more of a capacitor than a galvanic or a chemical reaction taking place. I don't know. The chemists that know these things can figure this out. Like I say, this stainless steel is the non-magnetic, which I believe is a 304 grade. Okay, now the other thing I wanted to show is if I go ahead and zap it with a 9-volt battery, this is going to go on up and run. And there goes the motor running, and there's the charge I just put on that from tapping that battery. And there goes the motor. Now, if I put that battery on there for about 5 seconds, 10 seconds, this will run for 15 minutes. Granted, it's a very, very low amp draw motor, but you can see the charge going off of it right now. That's discharging out of that cell through the coils. Each coil is about 30 ohms, and there's 8 of them. And when that reed switch opens and closes, it pulses out through that coil chain, but it's also generating at the same time. You can see this is going on down. Now I'm going to stop this again here. Watch this rebound. This is that rebound effect. Now batteries will do this, and capacitors will do this with dielectric absorption. But I thought it was interesting, so I thought I would share this with people. And anyway, the study that I'm doing right now with electricity and such, it all interrelates to chemistry too. And I've been really fascinated with the interconnection of things. And the more I study, the more I am fascinated by how everything's connected. Thanks for watching.